The number of electrical surges per day in a large transmission network can be modelled by a Poisson distribution. Over a long period, 30% of days are experiencing no surges. Calculate the mean number of surges per day. So, what we've got there is a back to front problem. We've got the probability that x is equal to 0 is 30%. Okay? So it's almost a trick question. Over a long period, 30% of the days have experienced no surges. So the probability of x being 0 is 0.3. Calculate the mean number of surges per day. So this is where your calculator cannot help you quite the same way. You go back to the original formula, which is on your formula sheet, about the Poisson distribution, where the probability of x being equal to x equals e to the negative lambda, lambda to the power of x over x factorial. Then we know the probability of x being equal to 0 equals 0 factorial equals 1. Okay, so that disappears. Lambda to the power of 0 equals 1. So that disappears. So I get e to the negative lambda. I'm not sure if that actually comes on your formula sheet or if you have to just know it or derive it the way I just did. So what that tells me is e to the negative lambda equals 0.3. Now I need to think of logs, which I happen to love. Base to the power equals quotient, log b, quotient equals power. So rearrange this, it's base e, so I can say log e of what? My quotient equals negative lambda. Yeah?
Yep.
That's fine. But this log e, you don't actually write. What do you write instead? Yeah, ln. Yeah. So I know that ln3 equals negative lambda. So now this is looking sweet as. I just need to find my log button.
I got that.
Where's that?
Previous.
Where's my log?
Look, it's
Oh,
the log.
it's just a log, just an ordinary log thing. ln, no fancy button, it's already there. 0.3, the calc students can tell me that, equals that. And then it's just, that's already got a negative sign, so lambda equals 1.204 with a bit of rounding. So I'll check my answer. Okay, so that's correct, that's sweet. Number 2, on average, there have been no hurricanes in the Gulf of Mexico on only 15% of years for which records are kept. Assume that hurricanes occur according to a Poisson distribution. Estimate the mean number of hurricanes in the Gulf of Mexico per year. Alrighty, so I'm just going to move that up. Can we remember that off by heart? So we've got the probability of x equal to 0 equaled e to the negative lambda. Is that correct? Yep. Okay. So what have we got? We've got the probability of there being no hurricanes equaled 15% of the years, 0.15. So we know that 0.15 equals e to the negative lambda. So natural log of 0.15 equaled, or negative that equals lambda. Just doing a bit of algebra there. So I'm going to go minus ln 0.15 and I get 1.897 and check the answers. That is correct. Nice practice, much easier second time. Okay, so 22.06 is a bit harder, so let's go for it. 22.06, number 1. The number of pieces of litter at the side of the road has a Poisson distribution with a mean of 3 per 10 metres. Okay. Calculate the probability that there will be fewer than 4. Probability that there's going to be less than 4 of litter in a 30 metre section of the road. So if I've got 30 metres, remember with Poisson, that's per 10 metres. So what does my lambda change to? Yeah, I had to multiply that by 3. That's a time sign. Multiply by 3. So I need to multiply that by 3. So my lambda's 9. But I've got less than 4, which is the same as the probability of x being less than or equal to 3. Am I correct? Because my calculator button, it's got to be less than 4. So it can be 0, it can be 1, it can be 2, it can be 3, but it can't actually be 4. Yes? Fewer than 4 does not include 4. So back to menu, back to stat, distribution, find the right distribution, and we are PCD, quite correct. And our x is less than or equal to 3, and our lambda has been adjusted to be 9, and we've got 0.02123, and check. Usually we do, but not always. Laughter aside, we actually did get that correct. Alright, next one then. What is the probability that at least one piece, so I'll just get rid of that. So what's the probability at least one? What does at least one mean? At least one, so that could be 1, 2, 3, 4. So it's the probability x is greater than or equal to 1. Yeah? Calculator doesn't have that button, so it's got to be 1 minus the probability of x equal to 0. Yeah? Okay, we're in business. What is the probability that at least one piece of litter can be found at the side of the road, at the side of each of 10 separate 10 metre sections of road? 10 by 10 metres sections. So let's find it for one 10 metre section first. Okay, so for one 10 metre section, our lambda was 3 pieces. Yeah? Lambda's 3 pieces. So we're going to have x being 0. Doesn't actually matter which. If we go PCD or PPD, it'll give us the same answer. And lambda is 3. So that is 1 minus 0.049. I'm just going to go 8. Okay. Go back here and go 1 minus 0.0498, and so we've got 0.9502. So it's a bit of a trick because it said, what's the probability that at least one piece of litter can be found at the side of each of 10 separate? So if they're 10 separate, what are we going to do with them? Remember your probability trees? You multiply, so what are we going to do with this? The 0.950 power of 10 was coming from the back. Yeah, okay, nice. Nice little voice from the back of the class. To the power of 10, to the power of 10, try to the power of 10. Okay, and that rounds very neatly to 0.6. crikey. That's a 0. 0.6000, is it? They've actually got something else in there. I don't know. I'm rounding to 0.6 on that one. Could be a rounding area prematurely. Okay? Cool.